All right, well thank you for showing up. I am going to talk to you about Marvell today. So we are a little bit of a newer player within HPC and SC and all the fun here. So I'll give you a little bit of a background on the company, and then I'll talk more about from a product standpoint and customer and some interesting things that are happening actually just this week. So Marvell's been around for quite a while, since 1995. We're about a $3 billion revenue company based in Santa Clara in California with engineering facilities around the world. And we are very much an intellectual property company in terms of, you can see the number of patents here, very focused from an engineering perspective, and we are a silicon company. So silicon across a range of the infrastructure. Our heritage really goes back to storage IP. Pretty much every storage controller out there today uses Marvell IP and technology. Very strong in the networking space, Ethernet switches, PCIe Ethernet cards, and intelligent NICs. Where we've really expanded, and the group that I represent is our server technology. So a little bit over a year ago, Marvell purchased a company called Cavium. And Cavium is where the Thunder X ARM server product line originated. And today we're the main part of Marvell as you think about the compute aspect of the things that we're doing from a Marvell perspective. We have a long track record in building processors, especially in the ARM space. And I'll talk to you more about what we're doing at the high end, but at more the embedded space and in the networking processor space, we have product lines called Armada, and Octeon and Octeon TX. So we've shipped many, many billions of CPUs over the years. And we've really focused on multi-core optimization and multi-core silicon. So that's really our claim to fame and a lot of our expertise. We have a long track record working with ARM and deploying ARM in a number of different use cases and market segments. One of the things you'll see Marvell reference to a lot these days is the 5G market as we expand our solutions in that space, and you'll continue to see more and more about some of our wins and some of our successes in that 5G market. But what I want to talk to you more now about is what we're doing in the server space with our Thunder X product line. So as I mentioned, we are built on the ARM architecture. ARM is somewhat of a newer player in HPC in particular, but we really think it is the wave of the future from a compute and a high performance standpoint. So if you look at the ARM ecosystem, basically you probably all have ARM devices literally physically on you right now. A phone, a watch, a sensor, certainly in your home. And over time, ARM has actually shipped over 100 billion processors throughout their ecosystem. And that continues to grow with the expectation of another 100 billion over the next 4 years. So we're able to leverage a very strong ecosystem, strong IP development that historically has been focused more on the client side. But because of that client start, very, very efficient from a power efficiency standpoint, from a space, from a die implementation standpoint. And now as the architectures continue to evolve, and as we partner with ARM, you're seeing more and more from a high-end performance standpoint. So ARM is an IP company, an IP licensing company. So as Marvell, we license that IP and that architecture, and we optimize it for our implementation. And so we will do microarchitecture optimizations and specific things for use cases in an HPC market in more of a data center use case. So ARM is well suited across multiple areas of deployment. We'll talk more about what we're doing in HPC here today, but also in the cloud space for scale-out workloads. The ARM native Android use case is interesting. So I talked about most of you, the phones you have are going to be ARM-based. Well, it's not that much of a stretch to take those applications running on your phone or running them on the cloud natively on that same ARM architecture. So think of gaming, think of CI or CD. a number of extensions and use cases that are continuing to expand from a cloud standpoint that we can run with many, many VMs running natively on our technology. And that extends out to the edge as well. I mentioned 5G, but you're seeing more and more use cases that kind of gravitate between the core and the edge, and as we have those ARM deployed CPUs, we can span those different spaces very, very well. Okay, so Thunder X2 is our deployed CPU today. It's easily the most broadly deployed ARM server processor. It is based on the ARM 8.1 architecture. I won't go through all of the specs here as I talk to you, but what I do want to highlight is I talked about how we're an architectural licensee. So things that we've done that are unique and we're first to market with ARM, things like our out-of-order support and up to 4 threads per core. We were the first ARM vendor that supported cache coherency and dual socket. One of the things that has allowed us to be very successful with Thunder X2 is our expanded memory subsystem. So 8 memory channels, which really gives you a very balanced compute memory solution. 56 lanes of PCIe Gen 3. So a lot of the kind of classic capabilities that you're used to in other architectures, now we've successfully deployed within an ARM architecture. And that processor has been in production for well over a year. Now we're deployed in some really interesting areas, although this conference obviously is more focused on HPC type deployments. We actually have done a lot with Microsoft in Azure. So we just had another public update last week about our production deployment at scale within Azure for many of the infrastructure use cases at Microsoft. So it's not the external VM support, but it is the internal heavy lifting of all the infrastructure that has to take place within that Azure infrastructure. And it's the first time that Microsoft has deployed a non-x86 platform within that environment. So a major step from an ARM perspective and an ARM ecosystem. So Microsoft bringing Windows Server, compilers, tools, all the key applications over to the ARM architecture with Thunder X2. We've had a number of success wins within DOE kind of labs, so Los Alamos, and Cray is our vendor at Los Alamos. Sandia with HPE. Sandia's claim to fame is in the top 500, first ARM system in the top 500. You see a number of other deployments that we've had that have been quite public, many others that haven't been as public. Catalyst is an interesting program, and it's appropriate that we've got DDN's HPC wire plaques up here. We received our own HPC wire plaque, and that was part of the best collaboration. So Catalyst is a program that we've been working on for well over a year with a number of industry partners, as well as 3 major labs within the UK. University of Bristol, Leicester, and Edinburgh, EPCC. And so here you can see it's an HPE Apollo 70 cluster that has been deployed at each of those 3 sites. Each of the sites has targeted certain workloads and areas that they want to optimize for and expand. And in particular, it's worth calling out that EPCC has been very active in bringing Lustre Server to the ARM infrastructure. And I'll talk a little bit more about that, but it's appropriate given the presentation in the DDN booth today. One of the things that has really been important too, and that's where this collaboration comes out, is we've worked with Mellanox on the InfiniBand side, SUSE with SLES, and then HPE obviously, and ARM as our IP partner. So it's been a great collaboration. You're going to continue to see more and more about it, and we were really honored to be recognized within the industry as part of that. So one of the areas that we focused a lot on relative to the ARM side is the overall software ecosystem. It's important that you as end users or partners can take ARM-based systems and quickly bring them up and run your own applications that you historically have been able to use on other architectures. So as you can see from this slide, we really have complete top to bottom support from our OS partners, tool chain, compiler, middleware. I talked about Lustre. And more recently, we focused a lot on our third-party commercial ISVs. Take EDA as an example, electronic design. So this is a case where companies like Marvell, as we build our silicon, we use some very heavy simulation engines, either from Cadence or Mentor, for example, to run those simulations. It's a very heavy compute workload. And this is a case where we've partnered with Cadence, for example, and done a number of third-party white papers and performance analysis. And this is also a case where we can consume those licenses ourselves and test those. So that's a good example of now where you're seeing more and more commercial ISVs. You also see presentations this week from Altair on Radios, Ansys with Fluent, Open Foams, that CAE market as well. And you'll continue to see more and more of the commercial ISVs coming along. One of the most exciting announcements for us this week has been our partnership with Nvidia. So this was first announced at ISC just a few months ago in June in Frankfurt. And if you had the chance to see Jensen's keynote presentation yesterday on Nvidia, or if you've had a chance to go over to their booth, you've seen how quickly they've been able to move to full support for the ARM architecture using Thunder X2 as the major reference platform, bringing that stack of well over 600 HPC and AI applications over. HPE Apollo 70, that platform I talked about that's been deployed at Catalyst, has an option to support multiple GPUs in that configuration. The PGI compiler is included in this effort. So it's really an exciting expansion of the ecosystem, and yet I think another good example of how different partners and different solutions continue to come on board from the ARM market. Okay, so DDN and Marvell, what's the connection, what's the collaboration? So last year, DDN announced commercial support for Lustre Client on ARM servers. That Astra system that I talked to you about, the top 500 system, fully uses the Lustre Client today. And then, again, as I mentioned with the Lustre server, that's been part of the output of our Catalyst engagement, getting Lustre server enablement there on the ARM platform, seeing that deployed more broadly, working in the upstream, both directly, Marvell and the WAM Cloud team, but then also other industry groups like Lenaro. So we continue to see areas to optimize and build on that, and other areas with DDN over time that I think will be quite exciting. So I talked about the Nvidia announcement this week. I talked about our HPC wire recognition. We're in a number of booths here across the show. So we are booth 349, so a little bit back on that side. You'll see demos at the SUSE booth running some AI applications on one of our reference workstations with SLES 15. The Nvidia booth, OSS, the One Stop Systems, has what they call JBOG, just a bunch of GPUs. So that's 8 GPUs connected via NVLink, then via PCIe to Thunder X2, ARM, and just a number of other partners. So I think that really goes to the focus and the priority that we place on our overall partner community. We've also had a lot of investments on our on partners investing in us, right? So DOE with Los Alamos, this was announced not quite a year ago. And then ARM has also invested in some of the work we're doing. So it not only are we organically growing, but also some of our partners see the value that we bring to the market and the opportunities that we're really bringing in. So that's another way for us to accelerate the development that we're doing, and in particular on our roadmap. So as I mentioned today, we're shipping Thunder X2 in 16 nanometer. We have announced Thunder X3, which will be our follow-on processor next year in the 7 nanometer space. And we are able, because of some of those investments, because of some of the growth that we've had, to also have parallel development between our next and our follow-on generation Thunder X4. So stay tuned on that. We'll continue to, as we get into next year, disclose more and more of the details on what we're doing there, as well as some more deployments that today aren't yet public, but soon will be. And with that, I think I've kept us reasonably on time.
I think so. I think that
thank you.
sounds great. Anybody have any questions?